Hi everyone, this is Dr. Nak and we are about to go over the practice exam number 2, part 1. You may use your little scientific calculator if you like, but for this portion of the exam, you're not allowed to use the graphing calculator. But anyways, let's just get started. So number 1, find the exact value of the following under the given conditions. So what do we got? We got tan of alpha equals -4/3, and the alpha better be between pi over 2 and pi. All right, and then cosine of beta is 1/2, and beta better be between 0 and pi over 2. So first what I'm going to do is I'm going to draw the picture, and let's just see what's going on. Okay, so for the alpha, let me see, tangent is -4/3, so it's going to lie in quadrant 2. Pretend that's a right triangle. So this is going to be 4, and this will be -3, and this is our alpha. Now this, the hypotenuse is going to be what? Our r is going to be square root of 16 plus 9. So this is going to be what? This is 5. And here we go. All right, because remember, this is pi over 2, and here is pi. So our angle has to be between those two. Okay, now for the cosine of beta, let me just draw that situation. And 0 to pi over 2, so here's 0, here's pi over 2. So it's going to look, let me just draw the right triangle like this. And what cosine of beta is 1/2, so this is going to be our beta. And this is 1, 2, and this should be what? Square root of 3. Okay, so first part A, find the sine of alpha plus beta. So first what you need to do is, since you're going to see something very similar to this, you're going to have to memorize the formula for it. So let me just write it down in red. Sine of alpha plus beta. This is sine of alpha, cosine of beta, and plus cosine of alpha and sine of beta. Okay, so what we're going to do is we're going to follow that through. So let me just change the color on the pen. All right, so this is going to equal to, all right, so let's look at the sine of alpha. So we're looking at the left picture over there. Now sine of alpha is going to be what? Sine better be positive in quadrant 2, so it's going to be 4/5. And cosine of beta is given to you, so it's going to be 1/2. And then plus, now cosine of alpha is going to be, what is that? -3/5. And sine of beta is going to be sine of beta is going to be square root of 3/2. All right, so then what do we get here? We're going to have 4/10 and minus 3 square root of 3/10. Always simplify your answer all the way. So this is going to be 4 minus 3√3 whole thing over 10. I believe this is going to be the answer. So I'm just going to write our answer over here. 4 minus 3√3. Sorry, that's a minus sign. Whole thing over 10. Okay, moving right along. Part B, find cosine of alpha minus beta. So again, we're going to have to know the formula for it. Let's write them out. Cosine of alpha minus beta. This is going to be cosine of alpha, cosine of beta, plus sine of alpha and sine of beta. Okay, now what we're going to do now is we're going to fill in the blanks. So let's go. So the cosine of alpha is -3/5. Cosine of beta is 1/2. And plus sine of alpha is 4/5. And sine of beta is √3/2. Okay, so now let's simplify this. So here what we're going to get is -3/10 and plus 4√3/10. Okay, so this is going to be -3 plus 4√3 whole thing over 10. So let me write down the answer on this box. Plus 4√3 whole thing over 10. Okay, moving right along. find tangent of alpha minus beta. So again, let me write down the formula. So tangent of alpha minus beta, this is tan of alpha minus tan of beta, whole thing over 1 plus tan alpha and tan beta. Okay, so now let's fill in the blanks. So this is going to equal to what? Tangent of alpha is -4/3. And then minus tangent of beta is going to be what? √3 over 1. Whole thing over, oops, didn't mean to do that. Whole thing over 1 plus tan of alpha is -4/3. And tan of beta, that's a negative there, and square root of 3 over 1. Okay, now what I'm going to do is this. We're going to have to simplify this all the way. So what I'll do is I'm going to multiply the top and the bottom by 3 to get rid of that denominator. Okay, so if I multiply by 3, what do we get? We're going to get -4 minus 3√3 over 3, it's going to be minus 4√3. Okay, now what? Now let's rationalize the denominator. Please don't hate. Alright, so here what we're going to do is we're going to multiply here by 3 plus 4√3. That's a 3 there. And then 3 plus 4√3. Okay, so if I do that, what are we going to get here? I'm running out of room. Okay, so this is going to equal to what? Let me see. -12 minus 16 square root of 3 minus 9√3. Oh no, I'm running out of room. Minus 12 times 3. Oh my gosh. Whole thing over, what is that? 9 minus 16 times 3. Oh my goodness. I'm so sorry, you guys. I hope you can follow my work. But regardless, what we're going to get here is -48 minus 25 square root of 3, whole thing over -39. Now, since we got too many negatives going on, just factor out the negative from the top and the bottom, and your answer is going to be what? 48 plus 25 square root of 3, whole thing over 39. Tight squeeze in there. So 48 plus 25√3, whole thing over 39. Okay, number 2, use a sum or difference formula to find the exact value of cosine of 7 pi over 12. Okay, so if you don't like radian measure, convert that into a degree measure so that you got a better understanding of what kind of an angle that you're dealing with. So how do we do that? Okay, let's solve. Let's see, 7 pi over 12. Now the conversion is what? 180 degrees over pi. Simplified a little bit. What do we get? Cancel out the pi, and here you're going to have what? 105 degrees. Okay, so now let's fiddle with this and see. Let me see. So note, what plus what will give me 105? The angles that we know of. Maybe 45 plus 60, 60 degrees. All right, that's going to give us 105 degrees. So in this case, it's what? Pi over 4 plus the pi over 3 equals 7 pi over 12. All right, so let me just put that in a little bracket as a note. All right, now from here, since we want to compute cosine of 7 pi over 12, what I would like to use is the cosine of alpha plus beta. So let me just write that out. So note that cosine of alpha plus beta, this is cosine alpha, cosine beta, change the sign, and then sine alpha, and then sine of beta. Now, our alpha is going to be pi over 4, and then let's call beta to be pi over 3. Okay, so that implies that the cosine of 7 pi over 12, right? 7 pi over 12. Now that's nothing but the cosine of pi over 4, and then plus the pi over 3. So let's just follow the formula. So this is going to be cosine of pi over 4, cosine of pi over 3, and then minus sine of pi over 4, and then sine of pi over 3. Okay, so now from here, I think we're good to go. So cosine of pi over 4 is root 2 over 2. And then multiplying here by cosine of pi over 3. So pi over 3 is 60 degrees. So I don't know which way you do this, but I always do it with a triangle. So this is pi over 3, length are 1, 2, root 3. So cosine is adjacent over height, so it's going to be 1/2. And then minus, now sine of pi over 4 is root 2 over 2. And then sine of pi over 3, sine is opposite over the height, so root 3 over 2. Oh no, I'm running out of room. Okay, so then it looks like this is going to be root 2 over 4 minus the root 6 over 4. Yeah, so you can keep it like this or just put it into one fraction, so which is root 2 minus root 6 all over 4. And you know what? I'm just going to box that for our final answer. Okay, number 3. Given that cosine of theta is negative root 6 over 3 and theta better be between pi over 2 to pi, find the exact value of each of the following. Okay, so you know my routine. I always draw the picture. Okay, so here's pi over 2 and here's pi. Our angle must lay in here, so pretend that's a right triangle again. So you got a cosine of theta is negative root 6 over 3. So here you're going to have negative root 6, and then here's 3. So that means our missing length, let's just compute that as a y, it's going to be what, 9 minus 6, which is going to equal to square root of 3. So this missing length is square root of 3. Okay, so I think we're ready to go. So let's first go with part A, sine of 2 theta. So again, you're going to have to memorize this formula. Sine 2 theta is 2 sine theta cosine of theta. Okay, so what we're going to do now is we're going to fill in the blank. So this is going to equal to 2 times sine of theta is root 3 over 3. And the cosine of theta is given to us, negative root 6 over 3. Okay, so now what do we get over here? So this is going to be equal to what? Negative 2 square root of 18, whole thing over 9. You can simplify the square root of 18 a little bit. So this is negative 2 times square root of 18 is what? 3 square root of 2, whole thing over 9. So this is negative 6 root 2 square root of 9. I mean, not square root of 9, over 9. And so this is going to equal to what? Negative 2 root 2 whole thing over 3. So here it is. So I'm going to write this as an answer. Negative 2 root 2 whole thing over 3. Okay. So now let's go with part B. Find cosine of theta over 2. So again, you're going to have to memorize this formula. Let me write it out. Cosine of theta over 2. This is going to be plus or minus the square root of 1 plus cosine of theta whole thing over 2. Now the plus or minus is determined by the quadrant of the angle theta over 2 is going to lie in. Okay, so let me write that out. So this plus or minus is determined by where the theta over 2 lies in. All right, so first note that your theta is given to be between pi over 2 to pi. That's the given information under number 3. So let me just make a note. So we have note. We're given theta was between pi over 2 to pi. So if I want to find out where the theta over 2 is going to lie in, I should multiply everything by 1/2. Alright, so in that case, what do we get? Pi over 4. And then here you're going to have theta over 2. And then here you're going to have pi over 2. So our theta over 2 is going to lie between pi over 4 and pi over 2, so which is in quadrant 1. Alright, so now let me just draw the picture. Okay, so pi over 4, here to here is pi over 4. So pi over 4 and theta over 2 is over here. And here is your pi over 2. Okay, so let's do this. So that means what then? Our cosine in quadrant 1 is positive. So what you're going to do is you're going to take the positive side of that square root of 1 plus cosine theta over 2. So let's just do this. So therefore, this is going to equal to positive square root of 1 plus, now cosine of theta is negative square root of 6 over 3. Whole thing dividing by 2. Alright, so let's simplify this nastiness a little bit by multiplying here by maybe 3 over 3. I think that might work out nicely. So if I do that, what are we going to get? We're going to get square root of 3 minus square root of 6, whole thing over 6. And I'm just going to leave my answer the way it is. So the answer is square root of 3 minus square root of 6, whole thing over 6. Number 4, established identity. When you prove trig identities, please show all of your work and do not skip any steps. But anyways, let's start out with number 4. To prove that, you're going to have to choose either the left-hand side or the right-hand side to begin with. So what I'm going to do is I'm going to start working from the left-hand side. So I'm going to write left-hand side equals, let me just copy. So you got cosine of x minus y, whole thing over sine x cosine y. Okay, so let's do this. All right, so let's first expand out the cosine of x minus y. So the identity is what? Cosine of x, cosine of y, plus sine of x, and then sine of y. Now whole thing over sine of x, and then the cosine of y. Okay. So now what should we do? Maybe we can separate those two expressions on the numerator. So maybe we could go cosine of x, cosine of y, whole thing over sine of x, cosine of y, plus sine x, sine y, whole thing over sine of x, and then cosine of y. Now if we get stuck, we'll just cry together and we'll try to do something else. But anyways, what can I do here? Let me see. Could cancel out the cosine of y and maybe the sine of x. Are we in good hands? Alright, so what do we got? We got cosine of x over sine of x plus sine of y over cosine of y. Looks good. Now cosine over sine is what? Cotangent. Plus sine over cosine is tangent. Oh, look at that. That's exactly the right-hand side. So we're done with this problem. Okay, number 5. Okay, so obviously the left-hand side looks a little bit more complicated. So what I'm going to do is I'm going to work from the left-hand side. Okay, let me copy and paste the expression. 1 minus what? Cosine square of theta over 1 plus sine theta. Okay, now let's see. Cosine square of theta. Okay, so that one has quite many identities, but maybe we can use Pythagorean identity. So let me just write this out. So please note, you're going to have to memorize this, right? Remember, sine square of theta plus the cosine square of theta equals to 1. So that implies that cosine square of theta is 1 minus sine square of theta. Okay, so let me try to use this in place of cosine square that we see here. And again, if we get stuck, if it doesn't get us anywhere, then we'll just try something else, that's all. Alright, so we got 1 minus cosine squared. Make sure to put this in the parentheses. 1 minus sine square of theta. Now whole thing over 1 plus sine of theta. Okay, so now let's stare at this for a little bit. Okay, so note that, let me see. If you have 1 minus x squared, you can factor this into what? 1 minus x and then 1 plus x. So if you don't believe it, just, FOIL it on the right hand side, and then it should equal to the 1 minus x squared. But anyway, so that implies that, let's see, we have 1 minus sine square of theta. Okay, so if I follow the formula above, then here you're going to have what? 1 minus sine of theta, and then 1 plus sine of theta. Okay, so let me just use that. So you have 1 minus sine of theta, and then 1 plus sine of theta, whole thing over 1 plus sine of theta. Okay, so notice that we can cancel these two. So what do we got? We have 1 minus, I'm going to distribute the negative, 1 plus sine of theta. 1 minus 1 is 0, so we're left with is sine of theta, which is the right hand side. Yay! I got lucky on this one. All right. Number 6. Okay, so obviously the left hand side looks a little bit more involved, so I'm going to go with the left hand side equals. So we have what? Cosine of 3 pi over 2 and plus theta. All right, so let's just follow it through. So note that cosine of alpha plus beta, this is cosine of alpha, cosine of beta, minus sine alpha, and then sine of beta. Okay, so our alpha here is going to play the role of 3 pi over 2, and beta is just going to be the theta. So if I expand this out, then we get cosine of 3 pi over 2, cosine of theta, minus sine of 3 pi over 2, and then sine of theta. Okay, so now let's compute. Cosine of 3 pi over 2 is 0, so we have 0 times cosine of theta, and minus sine of 3 pi over 2 is negative 1, so we're going to have negative 1 times the sine of theta. Okay, so this is what? 0 plus sine of theta, which is going to equal to sine of theta, which is what we're trying to show. number 7. Okay, so you can pick either side, but I'm gonna go with the left hand side and see what happens. So let me see. So left hand side equals, now let me just copy and paste, cosine of 2x, whole thing over what, 1 plus sine of 2x. Okay, so I used to hate cosine of 2x because that thing has so many different types of identities, but let me just write them out because who knows what we need for this particular problem. So we have cosine of 2x. Now that one of the identity is 2 cosine square of x minus 1, which is same thing as cosine square of x minus sine square of x. And another one was what? 1 minus 2 sine square of x. Alright. So let me see. On the right hand side, we're going to have to establish cotangent of x minus 1 over cotangent of x plus 1. So you know what? Let me use the second identity, cosine squared minus the sine squared. Alright, now if that doesn't work, we'll just try something else. Okay, so I'm going to replace the cosine of 2x with cosine square of x, and then minus sine square of x. Now on the bottom, I'm just going to keep it as 1 plus. Alright, sine of 2x, that's another identity that we're going to have to memorize. So let me see, sine of 2x is 2 sine x, and then cosine of x. Okay, so here what we're going to get is 2 sine x, and then cosine of x. Alright, now let's see. You see that the top factors out, the numerator I mean, factors out nicely because, look at it, if you have, let me see, a squared minus b squared, that's a plus b, and then a minus b. Okay, so our a is going to be the cosine, b is going to be the sine. So if I do that, then I could factor it out as cosine of x plus the sine of x times it by cosine of x minus the sine of x. Alright, whole thing over 1 plus 2 sine of x, and then cosine of x. Okay, so I don't know about this. I don't know if I'm getting anywhere or not. Let me see. What else do you think we should do? How about this? Let's rewrite this one in terms of using sine and cosine. So what I'm going to do is this. Note that, another one, Pythagorean identity says what? 1 equals sine square of x plus the cosine square of x. Let me try to replace that 1 with this expression. So here what we're going to get is cosine of x plus the sine of x, cosine of x minus the sine of x, whole thing over. Now that 1 is I'm going to replace that with sine square of x plus the cosine square of x, and then what, plus 2 sine x, and then cosine of x. Alright, so now let's take a look. Aha, I see something. Okay, so note that if you have a plus b whole quantity squared, that's same thing as a squared plus 2ab plus b squared. Okay, do you see where I'm going with this? So let a to be sine of x and b to be the cosine of x. So let me just write it out directly below. So this implies that, so you see it better here. So if I have sine of x plus the cosine of x squared, this is same thing as sine square of x plus 2 sine x cosine of x, and then plus the cosine square of x. Isn't that exactly what we have over here in this denominator? Okay, so, if I rearrange it, I could rewrite it as sine square of x plus 2 sine x cosine x, and then plus cosine square of x. Okay, so let me just copy and paste the numerator. Okay, now the whole entire bottom is going to be sine of x plus the cosine of x, whole quantity squared. Okay, so now let's see. Now things are kind of looking good. So do you see that one of the term of the cosine x, sine of x, we can cancel them out. Okay, so if I cancel this, that means what? One term is going to be missing here. So here what we're going to get is cosine of x minus sine of x all over sine of x, and then plus the cosine of x. Okay, let's not try to forget what we're trying to prove. We need to squeeze out cotangent of x somehow. Alright, so what can I do? Cotangent is what? Cosine over sine. So, you know what? Maybe what we can do is this. Let's multiply the top and the bottom by 1 over sine of x. Okay, so that way when I distribute, I can produce cosine over sine, which is going to become cotangent. Okay, so if I do that, then here what we're going to get is cosine of x over sine of x minus sine x over sine x, whole thing over sine x plus cosine of x over sine of x. Okay, so this is same thing as what? Cosine over sine is cotangent, and then minus 1, sine over sine is 1, and whole thing over 1 plus cosine over sine is cotangent of x, which is exactly the same thing as the right hand side. Yes, I know cotangent of x plus 1 is on the bottom, but remember, addition is commutative, so I'm just going to leave it like this. This is good enough for me, so this is going to be the right hand side. Okay, that was a lot of work, a lot of tricks, but we got it. Okay, number 8. Consider the point given in polar coordinates, negative 2, 7 pi over 6. So what we're given here is r, theta. It's always in that order. Okay, so part A, it says plot the point in the polar coordinate system. Alright, so let me just draw the polar coordinate graph with the radial lines. So pretend this is of the radius 1. And here's the radius 2. Oh my gosh, pretend that's a circle, please. Alright, so over here, this is our negative 2. This is our 2. Okay, so again, if you're not too comfortable with radian measure, convert 7 pi over 6 into a degree measure. So what is that? 7 times pi over 6 is 30 degrees. So here what we're going to get is 210 degrees. Okay, so this is basically telling you this. Starting from negative 2, revolve positive 210 degrees. Okay, so from here to here is positive 180. And if I go up 30 degrees more, then we're gonna get 210 degrees. All right, so this point right here is going to be negative 2, 7 pi over 6. This is the answer right there. Part B. Convert the point to rectangular coordinates express your answer in exact values. Okay, so the conversion from polar to rectangular would be this. Please memorize this. I'll write it in red. X equal r cosine of theta. Okay, and then y is r sine of theta. Okay, so I'm just going to follow the recipe here. So this is going to equal to our r is -2. And here we're going to have cosine of theta, which is 7 pi over 6, which is same thing as -2. Cosine of 7 pi over 6 is -√3 over 2. So our answer is going to be, so our x coordinate is going to be square root of 3. Now y equals r sine of theta. So this is same thing as -2 sine of 7 pi over 6, which is -2 times sine of 7 pi over 6, -1/2, which is going to give us 1. Okay, so this is our x value, this is our y value. Therefore, as an ordered pair, remember rectangular coordinates always is represented by x comma y. So here what we're going to get is square root of 3 comma 1. Okay. Number 9. Consider the point given in rectangular coordinates, square root of 3 comma 1. Oops, I think I wrote the same coordinates as the previous example. Sorry about that. But anyways, find the polar coordinates of this point for r greater than 0 and theta is between 0 and a 2 pi. Okay, so here what we want is r comma theta. This is what we're looking for. Okay, so first to find theta, always use tan of theta equals y over r. Okay, so in this case, what we're going to get is what? We're going to have 1 over, oh, it's not r, y over x. Sorry about that. It's like, what's going on here? All right, so y over x. Whoops. So here you're going to get 1 over square root of 3. Okay, so that implies that, let me just rewrite it nicely. Tan of theta is 1 over root 3. So that implies that, what kind of theta do we got going on? So this implies that theta is pi over 6. Okay, I'm just gonna box that. Okay, now we got the theta, and let's go with the r. So to find r, always go with r equals square root of x squared plus the y squared. Okay, so in this case, what are we going to get here? X squared is square root of 3 squared, which will be 3 plus 1 squared is 1. So it looks like we're going to get 2. Okay, as you can tell, look at part A, wherever we plotted that point, -2 comma 7 pi over 6. Another representation of that will be what? Starting from +2 and go 30 degrees above, which is pi over 6 above, so which makes sense. So for an answer, I'm going to write it as r comma theta equals 2 comma and then pi over 6. And here you have it. Okay, so this is the first portion of your practice exam. If I made any mistakes or if you have any questions, please let me know. All right, I apologize. The volume has changed. I completely forgot to put my little microphone on the number 1 through number 9. So I'm sorry if I all of a sudden became super loud. But anyways, let's take a look at number 10. Find the norm of v minus w if v is 3i minus 5j and w is negative 2i minus 3j. So first what I'm going to do is, let's first compute v minus w to see what kind of new vector that we're going to get. So here, if I go v minus the w, then that is 3i minus the 5j minus whole quantity negative 2i minus 3j. Okay, so that's same thing as 3i minus 5j, and then it's going to become plus 2i and then plus 3j. Okay, now combining the like terms, so here we're going to have 3i plus 2i, so that's going to be 5i, and then here you're going to have negative 5j plus 3j, so that's going to be negative 2j. Now notice that this becomes a new vector, so let me just call this, just name it vector u or something like that, and let me just box this. Okay. Now, another way to write the vector in a cleaner way, I should say, you can always write it like this. U is 5 comma negative 2. So the first slot is your the value for A, and then the second slot is for the value for B, where your vector U is expressed in terms of, let me just write that out. So if U is AI plus the BJ, then I can write U as A comma B. But anyways, so this is the common notation that we'll be using when you get into calculus. And to me, this is much cleaner. So let me just box this. Okay, so now that means that the norm of v minus w is exactly the same thing as norm of u now. So let me just write that out, and let me just go like this. Norm of v minus w, that's exactly the same thing as the norm of u. Now you're going to have to know the formula how to compute the norm of u. Now norm of u is nothing but the length of our vector. You can think of it in that way. So here, do not forget this. The norm of u is given by the square root of a squared and then plus the b squared. All right, now let's follow it through. So here, what we're going to have is the square root of 5 squared plus the negative 2 squared. So this is square root of 25 plus 4, which is going to be square root of 29. So I'm just going to write that in the answer box, and we are done. All right, for the last problem, number 11, decompose v into two vectors, v1 and v2, where v1 is parallel to w and v2 is orthogonal to w. Let me just write that out as my side note. So the v1 must be parallel to w, and then v2 is going to be orthogonal, which is same thing as perpendicular to w. Now, in order for us to do this, our v1 is actually going to be the projection of v onto w. But anyways, let me just write down the formula for it, so make sure to know this. So v1 must be parallel to w. So the formula for that is going to be v dotted with w and whole thing over norm of w squared, that's same thing as w dotted with w, and then multiply that guy by w. I know, you're gonna have nightmares with all the w's in it. And then also v2, the formula for that is v and then minus the v1. Okay, so make sure to know that. All right, so now if you know that, then I think it's easy for us to compute. So I like my vectors look like in a vector form. So let me write it like this. So my v, where can I write it? So my v is 2 comma negative 3, and then our W is going to be 1 comma negative 1. Okay, so now I'm going to compute our V1. So the V1, let me just write down the formula. V dotted with W over W dotted with W, multiplying here by the vector W. All right, so ready? So this is same thing as 2 comma negative 3 dotted with W. W was 1 comma negative 1. And then whole thing over W dotted with W. So you're going to have 1 comma negative 1 dotted with 1 comma negative 1. And then don't forget to multiply here by our vector W, which is going to be 1 comma negative 1. All right, now from here, let's compute the dot product. So the dot product of 2 comma negative 3 and 1 comma negative 1, all you have to do is you multiply the first components together, then you add the product of the second component. So here we're gonna have, all right, step by step, 2 times 1 and then plus negative 3 times negative 1, and then whole thing over 1 times 1 and then plus negative 1 times the negative 1, and then here stays as a vector 1 comma negative 1. Okay, so computing this, what do we get? We're gonna have 2 plus 3 over 1 plus another 1, and don't forget to multiply here by 1 comma negative 1, that's a vector. So this is going to be 5 over 2 times 1 comma negative 1, so which is going to be 5 over 2 comma negative 5 over 2. All right, so if you want to, you can express your answer in that way, or this is exactly the same thing as 5 over 2i minus the 5 over 2j. Whichever you want to write is okay with me. So let me just box this. All right, so that's our V1. Now V2 is much simpler. So the V2, the formula is V minus the V1. So here our V was 2 comma negative 3, and then minus the V1, we just got 5 over 2 comma negative 5 over 2, which is same thing as, let's make this into a one vector. You're gonna have a 2 minus 5 over 2, and then comma negative 3, and then distributing the minus sign, then you're gonna have a plus 5 over 2. All right, so I'm running out of room as always, I'm sorry. So this is going to be, it looks like we're gonna have negative 1/2, is that right? And then comma negative 3 plus 5/2, that's another negative 1/2. Okay, so this is exactly the same thing as negative 1/2i and then minus 1/2j. Again, whichever answer that expression that I should say you want to write is okay with me. Okay, so those are the answers. So again, key is to memorize these two formulas here, and then also make sure to know how to compute the norm of a vector, and formula for that is over here. All right, so we are done with the part 1. Yay! All right, good job everyone, and let's kick some butt on exam 2. You got this.